Hello. Welcome to the Fundamentals of Reducing Utility Costs webinar. This is part of the Industrial Solutions Group World-Class Sustainable Manufacturing Training Series, and we'll be talking a lot about sustainable manufacturing as the day goes on. Appreciate everybody joining us today. I am Mike Burchak, Managing Principal of the Industrial Solutions Group. If you have questions as the webinar progresses, type them into the chat bar if you're listening live. We will also be posting this webinar on the internet, so you could ask questions later, just call or email. We'll also provide information at the end of the program as well. Just a quick snapshot of the Industrial Solutions Group. We're a network of a few companies and very experienced professionals that we focus on helping manufacturers achieve world-class performance. We cover several technologies, everything from automation, civil, structural, architectural, to process, utilities and HVAC work, logistics, environmental. Done a fair amount on good manufacturing practices, and then of course the different phases of projects: design, training, startup and commissioning, troubleshooting. We also stand out in a couple of other areas that we consider specialties. One involves economic studies and strategic evaluations. Best value option analysis. We really work hard to try to get proper decisions made, not just do projects right, but make sure that folks are doing the right project as efficiently and as effectively as we can. And then, of course, sustainability. And this webinar has to do with sustainability, master planning, gap analysis, loss elimination. So I appreciate you joining. Sustainability is one of those words that not many people talked about 20 years ago, but now everybody talks about it. You can't deal with an organization, a government agency that doesn't deal with sustainability, and everybody's got their own definition. I've just put a few on the list. Many of our customers think in terms of sustainability kind of in the old engineering fashion, where sustainability has to do with reducing energy costs, carbon footprints, water. Certainly that's a part of sustainability, but notice that in the public sector, the definition of sustainability has gotten much larger. People talk about the total employee, community, product safety. United Nations deals with better quality of life for all. National Council of Manufacturing, of course, brings in the concept of it's got to be economically sound and safe. So we've endorsed that broader sense of sustainability, but have summarized it in a few bullet points. If you want to be a sustainable world-class manufacturer, you need to do things safely. It's got to be safe for the equipment. That falls into a broad engineering category of process safety, pressure vessels, making sure things don't corrode, that they're safe to operate, that the equipment doesn't damage others, doesn't damage itself. Employees, industrial hygiene and safety, very important. Many manufacturers have departments for a number of years, decades, that have been focused on employees, and they should. And then, of course, safety for the community, environmental laws, various regulations. We need to make sure that our communities, if we're manufacturing next to them, are safe. The second broad category has to do with quality. It makes no sense to manufacture products that go out the door with a quality defect. Recalls are very expensive, but potentially even worse than that, defective products can actually cause harm to people. We've had recent examples of the romaine lettuce, potential contamination. So product defects do happen, and it's of utmost concern. And then finally, and we'll be focusing much on this area, reliable and productive manufacturing. And that means that you're optimizing the use of all of your resources, people, materials, energy, water certainly are part of that. So why is sustainability so popular? I think there are several reasons for it. One, it goes well beyond just cost savings. Sustainable manufacturers provide an image that's very important to a significant segment of the public. It is important to consumers around the world that they know that the products that they're buying are providing optimal use of energy, not warming the globe, etc. So it's very important if you want to sell products in the public sector that you can check off the sustainability block. Also, from a competitive standpoint, as we'll go through this, sustainability saves money. It increases productivity, it reduces costs. So if you want to have stable manufacturing sites, you need to be able to be competitive. And this sustainability idea is a key way of getting there. Makes it easier to meet regulations. Folks can get out of the compliance mode and actually meet the spirit of what the regulations mean and be very proactive. And that also sends a very healthy signal to your customers and your employees. It helps you attract good employees. There's a pride in being part of the best. When sports teams get into the postseason, it's hard work, but they have a lot more fun being part of a winning team than being part of the group of teams that are watching the winning teams on TV. And the same is true of all of us. We like to know that we're part of something that's winning and part of something that's on the cutting edge of what's happening. And finally, of course, investors, shareholders need to have happy shareholders and investors. Life is a lot easier that way. So it's a big topic. And the question is, well, where do you start? And I like the words of Lao Tzu that said, every journey begins with the first step. So that's very important here. We want to set appropriate goals, continuous improvement. And if we are consistent, taking one step after another and are focused in our intent, all of us can be world-class manufacturers. I think utility systems are a good place to start. There are many out there, many in the audience here that have started in other places. You can start in other places. It's a big journey, so there's no rule that says you start in one place or another. The important thing is to start. I'll make my case for utility systems, which is what we're talking. For one thing, it's kind of simple to wrap your mind around what's happening with plant utility systems. Now, I don't think a lot of our clients necessarily think of it this way. They'll think of every air compressor. They'll have 4 or 5 air compressors. Well, that's 5 air compressor systems. I've got 100 HVAC systems. That's now I've got 105 systems. Power transformers, number of them. So we got system after system after system. It can appear to be very complex. But I kind of take a step back and look at the manufacturing process. It doesn't matter whether you're making steel, jet engines, automobiles, consumer goods. Everybody needs power. Everybody needs compressed air. Everybody needs to heat something. They need to cool. They need to take care of bringing water in at the right quality and leaving water out of the plant. And you need to do that. You have 6 utility systems. You might have maybe nitrogen and other compressed gas. But sustainable plants are those that use these utility systems in a way that they work together. And that's how we deliver safety, quality, and great reliability and productivity. And utility systems are important for those features for total manufacturing, because a meeting like this ends very quickly if the power goes out. Similarly, you lose power in a plant, everybody is standing around not producing any product. So there's a leverage effect that comes with utility systems. They need to have high reliability, they need to have low maintenance, and that's what delivers good cost structure and good carbon footprint. They're also well understood technologies. We aren't dealing with space age rocket scientists here, and we don't want to with utility systems because they need to be reliable, they need to be cost effective. So how do we deal with sustainability? It's just a few steps. First, it's nice to know how much opportunity there is. We've referred to that as a gap analysis. Second, once we know what the opportunity is, then we can dig into the losses that are causing this gap, where we're at versus where we want to be. And then third, and the most important step, is actually eliminate the losses. And we'll be talking about each of these three steps here over the next several minutes. So let's talk about the gap analysis. Some people refer to this as the size of the prize. We're determining the size of the prize. We know there's money to be made based on our history with utility systems. But is it a little bit? Is it a fair amount? Or is it a whole bunch? It's kind of nice to know going in, because that helps to set priorities around the plant, helps to focus the teams that are identifying and eliminating losses. And fortunately, you can do this pretty quickly. It doesn't take a lot of effort to kind of get your arms around how big this gap is. I've listed here historic results. We've done dozens of loss analysis for a variety of different companies, and here are some ranges of the typical savings that we will get and we have found. So these are some actual results. And it's real easy to use this top-down analysis. You know, imagine you had a paper department that spends $1.5 million per year on purchased utilities. Now, if you wanted to, you could add maybe labor, maintenance, and operating costs to that, but we'll keep things simple in this webinar and deal with purchased utilities. Well, you go down the chart and you look at paper, and we said, yep, we do paper. We're seeing about 25%. 25% of $1.5 million, $375,000 per year. So that's the size of the prize. You might have a little bit less if you've been very active on sustainability. You might have more. You might have less or more depending on what your payout requirements are and how aggressive your company has been at funding sustainability. So this top-down analysis can happen very quickly. All you need to know is what your current costs are, but the problem with it is it's using some historic averages that may or may not be relevant to your particular site. So to deal with that problem, I also like to come at it from a bottom-up gap analysis. It takes a little bit more effort, but we are getting some information that's specific to your particular site. So we'll take this in a few steps. Let's say that you have a car and you're taking a trip and you're going for 50 kilometers and it takes a can of gas to get there. If I drive that car 100 kilometers, I would expect to use 2 cans of gas. Go twice as far, I use twice as much fuel. So in general terms, why wouldn't a factory be the same? We can graph what we just talked about with our cars. On the y-axis, we look at fuel used. We got cans of gas, 1 can, 2 cans. And then on the x-axis, we've got the distance traveled, number of kilometers. And you can see that we've got a straight line. If we don't go anywhere, we don't use any fuel. That's down here at the 0, point. If we go 50 kilometers, we use 1 can of gas. If we go 100 kilometers, we use 2 cans of gas. So real basic, simple concept. Part of the concept is how much do you use, but I put an X prime point in here to demonstrate how just a little bit of knowledge can be used and start the wheels turning a little bit on how to improve your plant, and this starts leading into world-class sustainability thinking. So you could ask yourself, what happens if I take the next trip to the same place? I go 50 kilometers, but 1 can of gas doesn't get me there. I find out that I used 10 or 20% more. Well, if I'm driving my car and my gas mileage is down, it makes me start to think, Maybe my air filters aren't working very well. Maybe I shouldn't have switched to that lower cost brand of fuel that has more ethanol in it. Maybe it's really not that good of a deal for me. Perhaps something else is happening. Maybe a brake is dragging. But bottom line is, when you're dealing with equipment, if it's not running efficiently, that is oftentimes a clue that something is starting to happen. And if I can catch it early, it's an ounce of prevention is worth a pound of cure. I can fix small problems like an air filter easily. But if I go on a trip and with a clogged air filter, I might be stranded someplace, and now I've got tow truck charges, and I've delayed, and I haven't gotten to an important event on time. Problems can steamroll, and that's what we want to avoid in a sustainable plant. Before we get into the rest of this bottom-up gap analysis, I need to introduce a couple of definitions. What do we mean by loss? And in my definition, we take a very broad definition. If you can't see what you're putting into something as part of the end product, the finished product, then it's a loss. And that actually often happens with utility systems. It's a very simplified explanation, but think of many of the manufacturing plants you all have been around. The raw materials come in at ambient temperature. The finished product goes out at ambient temperature. What happens to all the fuel that you put into a plant? There's not more energy in the finished product. All the electricity, you can't see that in the finished product. Instead, our utilities kind of act like processing aids, catalysts. We can't consume them. We know we don't consume energy. We don't consume water. So what we do is we use it for a while, and then we're very, very efficient at discharging things through stacks, cooling towers, drains. We have a lot of ways of getting rid of this energy we can't use, and we'll be talking about why we get rid of it and when's the right time to get rid of it. A few other definitions that you'll see as we talk about tier 1, tier 2, tier 3 losses. Tier 1, real easy stuff, low-hanging fruit. Turn off the lights when you leave a room. Fix the leaks. Tier 2, a little bit more difficult items. But they fit in a plant budget, but you have to do a little bit of work for them. Variable speed drives, changing out lighting systems, small bite-size projects that require a little bit of effort. The payouts are a little bit longer. Tier 3 items are those big ticket items. Let's change the chiller technology. Let's change the boiler technology. Let's introduce solar photovoltaic. When we go through, we also will classify some items as tier 4. Clients will say it's got to pay out in 2 years or 3 years. Well, there are some good ideas out there that might be good for a university that's willing to accept 7 or 10 year paybacks, but aren't working quite as well in the manufacturing facility because without government help or some big breakthrough in technology, they don't meet requirements. We'll throw those in tier 4. We don't like to throw them away because we never know when a new law might be passed or something that would bring those tier 4 back into the realm of feasibility. We can talk about this turn down ratio, what we were just doing for the cars in terms of a manufacturing plant. Instead of cans of gas on the y-axis, I've put utility usage units. Could be kilowatt hours. It could be millions of BTUs. It could be gigajoules. It could be cubic meters of water. On the x-axis, we have production units. Everybody knows how much they produce every month. 4,000 widgets, 8,000 widgets. And then we can look at the past 12 months data, and we can plot those, just an XY graph. And one thing you may notice, remember we had this nice straight line when we were dealing with our little car example. This is a typical scatter that you might get from your plant when you do this. Everything doesn't fit on a straight line usually. It's unusual that it fits on a straight line, but each of these would be real data points. And notice there's one data point right here that if we had a line from the 0, 0 point and started rotating it up, this plant, with all of the existing equipment, all of the existing production, proved to itself and its people that that month was a very efficient month for whatever reasons. We don't know why, but without spending any capital, any major capital, that plant can operate there. So what happens here? Why are we using 10% more or 20 or 30% more and not seeing much difference in production? So what we do in order to get our ideal curve is we go through that most efficient point and we say, well, that's where this plant can operate. We could plot a trend line between the data points and notice that there's a gap between the ideal curve and the curve. And if we crosshatch the area under that gap, that represents savings opportunities. If we could bring these average points down to the production line, and look at that, it's 20%. And I'd call those tier 1 and tier 2 items because I don't need to change fundamental system design in order to get there. We're dealing with maybe people that maybe their equipment's in warm-up mode too long. And we can find ways to speed up warm-ups. We can, leaks don't care whether you're producing any product or a lot of product, you get the same amount of leak. That will tend to make products go higher. So tier 1 and tier 2 items, this is kind of a picture of the kind of gap. Again, we don't know where exactly what the problems are that are causing the gap, but we can see a picture here that this plant has some opportunities. So we can take this a step further and do a little sample of, let's say that we've got a, this plant is planned to, their production schedule for next year is 6,500 units per month. So we can work through and we can use this bottom-up gap analysis to say, well, what's the potential savings? Well, how much would I expect if I went through this, process, this loss process? Now, I'll give you a couple of hints. We find that just because there's a gap, it doesn't mean you can get 100% of the way there. We usually divide that by 2. So we'll take those tier 1 and tier 2 savings and say it's pretty reasonable to get halfway there. If we're aggressive, maybe more. If things fall into place, maybe even more. But it's really hard to be perfect. But we don't have to be perfect to see some pretty significant savings. And we also find that with tier 3 items, and with tier 3 items, what happens is we can rotate this graph downward, that we can get as many tier 3 savings as we can tier 1 and tier 2 savings. Pretty easy calculation now. So at 6,500 units, the difference between the upper trend line and our ideal line is 11,500 units of utilities instead of 9,000 units. That's 128% of ideal. So we take that 28% divided by 2 and then add another 14%. Tier 3 equals tier 1 and 2. So we're saying it looks like that plant may have potential on that particular utility system to save about 28%. It's a good place to start. So let's get into the loss analysis process. It's a 10-step process. First, we need to assign a site leader, identify the systems. We usually break it out, look at 10, 12 systems or so. And then we will select a team for each system, develop a treasure map that tells us how much money is being spent on each system. And then it's an interview process. So we have teams, 3 to 5 people on the steam system, on the HVAC, the others, and we'll spend a couple of hours in a room. We'll tour the systems, start getting ideas on changes that could be made to this system in order to reduce cost. Then there's a period of quantifying the losses, revising, reviewing with folks, and developing an executive summary that gives a very detailed map of what the losses are and what the costs are. And then it's very important to celebrate success. These are ideas that are hard to visualize, and a little pat on the back a cup of coffee, something that says, hey, I appreciate the work done, goes a long way with the building the morale that we're after with sustainable plants. Here's a pie chart. This actually came from a project that we did last year. It's pretty typical. Where are the opportunities? Every system has opportunities. 60 to 100 ideas, pretty typical. So where do these savings come from? How is it that, we put in systems, and we've done loss analysis on plants that are 3 years old, and where does the savings come from? And I wanted to share a few keys that come from the technology that have helped me over the years to understand why we couldn't get 25 or 30 or even more % on some systems. The first has to do with quality, and I'm not talking about quality of equipment, and I'm not talking about quality of people or the quality of the training. Here, it's a thermodynamic principle. I'm dealing with quality of the energy or quality of the water that we are using. And many of our plants are set up that it's easier to use higher quality than it is lower quality, and we don't worry about this at all. But in terms of energy, you can start thinking through this. By higher quality, you mean higher temperature. Why is that higher quality in terms of thermodynamics? It's higher quality because I can do so many things with it. I can make electricity with it. I can use it for high temperature process heat. I can use it for all kinds of things, even the very low temperature users. I've got the same kind of thing going with water quality. We bring water in off the street. It's city water quality. We can drink it without becoming ill. But it's not nearly as good as it needs to be in order to make steam out of. And then if you need a CGMP plant where we're doing pharmaceutical grade or other CGMP critical products, you have to go all the way up to USP water, virtually pure. No minerals, no bacteria. Quality becomes very, very important on the water side, because higher quality is going to cost you a lot of money in equipment and operating costs. The second key that comes to play that we think a lot about when we get into sustainability is the reuse key. Once is not enough. We think of consuming gas, natural gas, like we're heating on the oven and it's gone. But we know that it isn't gone. Where it is it comes back, it's lower temperature. So the quality has gone. So we can actually reuse the same unit of energy multiple times. We can do the same thing with water. Kind of show a little staircase here on the energy side. So with ultra high temperature, this is 2000 degree, 2300 degree, this is natural gas, fuel oil flame temperatures. I can run that through a gas or steam turbine, steam turbine, of course, with a boiler. I can make electricity out of it. And then I am going to have discharged very high temperature exhaust. I can use that for specialty process heating. And then that product is going to be warm. I can reclaim heat from that. I can get down, I can actually make chilled water out of heat using absorption refrigeration. And then at the 140, 75 degree or so C temperatures, that temperature is really good for using for raw material warming, domestic hot water. And then think about the buildings that we heat this time of the year in the Northern Hemisphere. We're only heating to 23 degrees Celsius, 70 degrees. I can't go down a highway anywhere in the world in the winter without seeing a cooling tower operating in the middle of the winter, throwing away basically 100-degree heat, which is more than adequate to heat buildings with. So if you do a really good job, you don't use it once, maybe you use it twice. Some plants do use it once, twice. With cogeneration, you can start getting into even some better numbers. And there are plants around that have been operating a number of years using energy multiple times. You can do the same thing with water. And that's the final key. I would talk in terms of the re-empower key, where we don't want to throw away low quality energy and water. Sometimes we just give up too quickly. We could use heat pumps and we can reclaim the heat again, and we can use it another time. We can do the same thing with water. Good filtration systems, evaporation processes. There are other ways where instead of just discharging the water to the drain, we might be able to, it might be economical to clean it up and to reuse it one more time. So let's change speeds a little bit, or change gears a little bit. I want to give a few examples and it'll let you know where the savings are coming from. And one of the interesting things to me is you'll look at a list like this, and this is just a partial list. I had my my office manager go through the last few reports we did and just pull some tier 1 opportunities out of some reports. So there are many, many others. These are low cost. You know, if you have a leak, you can get paybacks in weeks sometimes, you know, maybe even days if it's a bad enough leak. But you aren't seeing anything on here that's surprising. At least I'm not in terms of, you know, space age technology. A lot of this, it has to do with how the teams are organized to look at things. When we get into these loss programs, a lot of times we find that even very skilled technicians, they don't know what a leak costs. They don't know what missing insulation costs. So a lot of times simple fixes just don't make the radar screen. I give you an example on leaks. Here are 3 different charts. Cost of a steam leak, cost of a water leak, cost of a typical compressed air leak. We can just start with a small one. A 1/8 inch leak, that's 3 millimeters. $3,800 US per year. Water, you're not just losing the water, but you're also getting billed for the sewer. Again, a 1/8 inch, 3 millimeter leak, $691 per year. Compressed air is a very expensive utility, same size opening, very near the cost of steam, $3,400 US per year. So leaks are very expensive. What does it take to fix them? Well, that steam leak that you see in the top picture, that's obviously a gasket that needs to be replaced. $3,800, you know, a good technician, shut down the line, you find some dead time, maybe you work on it in afternoon, you put in a few hours of work, and that work is probably already budgeted as part of the maintenance budget, and it pays out in virtually a couple of days. You know, it's very, very quick paybacks. Sometimes compressed air leaks, you see the technician using an ultrasonic gun. It's the best way to find compressed air leaks. Fittings come loose. That same technician that identifies a leak could actually fix the leak as he's going around and identifying. You can also look at leaks in terms of total plant. Here's a plant that has 4 air compressors and total installed capacity 5,000 cubic feet per minute, 8,500 cubic meters per hour. During peak production, this plant's running all 4 air compressors. That, by the way, is probably a tier 2 opportunity. If you can only get by with 3, you find that that's more efficient. But for whatever reasons, they're operating the 4 compressors now. But I really wanted to focus on this last one. On a holiday, on a weekend, you have no production, but you want to keep pressure in the lines. Most plants do. They have some instrument someplace that needs a little bit of air. They have something someplace that needs a little bit of air, even on a down day, maybe to keep the temperature transmitters working, or the or control valves modulating properly. But those tend to be small users, and in this plant, they're running 1 air compressor. They've done a good thing. They've turned off 3 air compressors, but they're running 1 air compressor at 3/4 load. Have been doing it for years. The trouble is those leaks are happening even during the peak production time. So that 700 50 CFM nominally is happening 8,760 hours per year. And the typical air compressor uses 1 horsepower for every 4 cubic feet per minute that it produces. If your power costs are 10 cents per kilowatt hours, some plants more, some plants less, that's 140 kilowatts that air compressor is using, and the annual cost of leaks $122,000 per year. So a leak prevention program probably makes sense on some frequency, and you can test your way into whether you do that once a month, once every 2 months, once every 3 months. Here's a list of some sample tier 2 ideas. Remember, from the definition, these are a little bit more complex. You have to spend a little bit of money. LED bulbs are a little bit more expensive than T8s. And maybe we're in the habit of, we don't have good metering, so we have to buy some meters, but with good metering and good billing practices, that can save a few percent on water bills, on electricity or steam bills. So with that, we have a little example, just a small packing room, 10,000 square foot packing room. It's very well lit. And people here have made a step. Probably when this packing room originally went in, everybody was using T12 bulbs, which are less efficient than T8s. But this LED light bulb world has really progressed quickly, and the technology has come out. So how much would you save if you just swap these out to T8 bulbs? You can calculate the 40% savings over 10,000 square feet, 2 watts per square foot. That's over $5,000 per year. Just by changing out bulbs. These T8s are going to burn out every year anyway, so you could make that part of a program. So within a couple of years, you've totally got LED lights. Could actually be more than that. If you notice as you get closer to us in the frame here, how the picture was taken, maybe they got some extra lighting fixtures in the walkway, and they'd really rather have the high light right over the equipment. So possibly this room might have a few extra fixtures, and you can actually goose the savings up a little bit more. And then we've got tier 3, and these are the bigger hitters. Again, chances are I need to get some appropriation outside of the plant in order to do that, but very important to do if you want to become world class. And here's an example. You see these air conditioning boxes all over the place on department stores, on warehouses, on manufacturing plants. Those 2 units that are shown kind of look alike, but they're very different in how much energy they use. The unit on top is transferring air like your home air conditioner directly to the outside air that can get very, very hot on summer days, particularly on top of a roof. The unit on the bottom is water cooled, and it's getting its chilled water from a chiller that's discharging through a water-based cooling tower system. Well, it turns out when you do that, it's a lot cheaper. A chilled water type system that's water cooled only uses 0.7 kilowatts per ton of cooling, as opposed to 1.1 kilowatts per ton of cooling for the DX unit. So if we had a 200,000 square foot building that was requiring 250 square feet per ton, which is a good average for a lot of non-heavy duty office manufacturing space, space that's not using high percentages of outside air, would even have a higher air conditioning load. But we can calculate the peak hourly savings. We know that the total installed tonnage would be about 800 tons based on that 250 square feet of floor surface per ton. And then looking at the difference in the power usage, kilowatts per ton, there's a potential savings of 320 kilowatts. and that comes out at 8 cents per kilowatt hour to $25.60 per hour. Now, getting a total annual number requires a little bit more analysis, climate trend data, that sort of thing. But you can see why many plants use water-cooled chillers. It's interesting to me that many plants have invested in water-cooled chillers, but then at some point, from a sustainability standpoint, will stub their toe a little bit and will actually start throwing in a DX unit here or there to save a few bucks on a little bit of chilled water piping. It always makes me wonder if they've really got a good understanding of, you know, what's happening to their system, and that they're starting to veer off from a more sustainable design to a less sustainable design. The end point on a loss analysis is an executive summary. There's total report. A lot of times it's 50, 75 pages, but it can be boiled down to 2 or 3 pages. It makes it easy for people to understand. And you notice, again, the savings, just like before, different, all systems have the potential to save. You see the same kind of dynamic here, where we're looking at potential savings by utility and by percent by system. So let's talk a little bit about the loss elimination process. Again, most important step. Unfortunately, you can't get to this step without doing step 2. But I like to think of loss elimination in terms of it's really an organizational challenge. Somebody has to decide, the leadership of the company, the plant manager, that sustainability is an important objective, and that plant leadership team is really a focal point, because I know plants get hit with so many requests, changes in production required, changes in product level. It is very easy for any initiative to get sidetracked. And without this steering team led by the plant leadership team, keeping focus and making sure that sustainability is in the top priority for the site, it can really start losing traction. So establish a steering team, and the job of that steering team is not to do the work. Its main job is to charter and lead the process through a loss elimination team, solid project manager, and then people from throughout the organization can supplement. Sometimes outside contractor help, sometimes you'll need engineering help, but a lot of times it's in-house technicians, departments that can lead, but somebody needs to keep driving the program and making it work and really bringing it to fruition. There are 2 really important implementation decisions that get made at this phase. One is which losses to tackle. And yes, remember, we've only budgeted to get rid of half of the tier 1 and tier 2 losses. It is okay to say we're going to live with this loss for a while. But it's very important to not do the way I was trained to do when I started my energy work a few decades back. What we'd always look for is the big item, the chilled water savings, as those were the big savings for. This process flips it around. It goes and it says, well, let's get the easy stuff first. In doing that, we get more efficient and more effective, and we can then get those tier 2 items. And now we're learning more about our systems, and we aren't using as much in the utilities. So when we get to the tier 3 items, which are really important, we don't have to buy equipment that's as big. And we may surprise ourselves by knowing the system better. Maybe a little bit of heat recovery is cheaper than buying a new boiler. And there's a better trade-off, a more sustainable path we can get ourselves on. And the capital costs can really start coming through and start making sense. I think another really important point that I want to talk about is what I'd call financial rules of engagement. The traditional approach that I see in manufacturing around the world is that projects get funded on a project by project basis. You want to change lights out in this room, put together an appropriation request, get it funded, change out lights in this room. You want to do it in the next room, put together an appropriation request and do it in that room. But with the program here that we've laid out, this sustainability program, I've also seen a lot of merit in let's looking at it as a total program that we want to finance, so that we aren't just going after each of these little ideas at the same time, because the paperwork can really become very, very challenging. So in a project by project approach, we would allocate separate resources prior to the elimination of each specific loss idea. On a program basis, though, we would allocate resources at one time up front. It's a multi-year program, 2 years, 3 years, 4 years, under the direction and discretion of the steering team. So it gives the team some flexibility as long as the results are there. And I wanted to go through a little example, because it gets to the heart of how, hey, this is fine and good, all these savings, but how in the world do you pay for them? And the answer is people are doing sustainability because it's the low-cost way of operating. If you think about it that way. So here I've got a little chart. On the y-axis, I've got US dollars. This is the cost of systems, the cost of what the utility is going to, or all of the utility systems in a plant. And then I've mapped out 10 years here. And we're going to go through 4 different scenarios. Scenario status quo says we don't do anything. We just keep going on, inflation 3% a year. We're going to spend more money year after year on utility systems, not worry about it at all. Base program says, let's knock off the easy stuff. That's tier 1 items. We can add tier 2 items, and now we've got a competitive program. Or let's go for the whole ball of wax. Let's see if we can't go towards world class and bring in some tier 3 items as well. So we'll go through these scenarios. So there is status quo, tier 1, without any savings opportunities. This is the glide path that a plant might be on currently if they're not doing anything. And most people are doing something. Well, something that would be easy to do is, well, let's get buttoned up. Let's get back to base and make sure we don't have any of these leaks. Make sure we're turning off lights when we leave rooms. We've got good programs. And you can see from the start, there's a positive cash flow that's starting. And over time, those really add up. So instead of 10th year annual operating costs being over $2.5 million, they're down to about $2.2 million. Makes a big difference. If you add tier 2 items as part of a program, I've done something a little bit clever here. And that is, I've said in the first year, notice that I've got some savings that are accruing from my tier 1 savings. Let's not throw those back into the corporate till yet, but let's just say I will not go cash flow negative. So I'm doing nothing more. I'm made my plant better because I've implemented tier 1 items, and now I've added some tier 2 items, totally paid for from the savings generated to date. So I've not hurt my cash flow at all. And now with sustainability, I can carry it one more. Now I've got the cumulative savings coming in from tier 1 and tier 2 items. And I'm saying that's going to, I can use that cash to help pay for tier 3 items. So it requires some corporate discipline. Surprisingly, with the way that capitalization works in many countries, this is actually profitable. You would show from the beginning your profits would increase because as you're spending capital, of course, action is out. So this is actually a little bit conservative from my standpoint. We're just staying on a cash flow even principle, and we're actually giving the company some profits as they go along. But boy, look what a difference happens as you get downstream because you've shown some discipline and focus up front. And we can graph that. We can talk in terms of net present cost and net present savings over a 20-year period. This is the equivalent of bringing all those cash flows back into current dollars by deducting out or factoring out a tax discount rate. Notice in the status quo, a 20-year net present cost, if we keep mapping out that curve for 20 years, that would be the equivalent of spending almost $25 million today. If we do the base program, we can knock that down to about 22 million with a big savings, 10% savings. Competitive program, we're less than 20 million, and the savings increase, and then look what happens with the sustainable world class. So in terms of what's your cost today, in terms of net present cost, and this is a measurement that that many financial people use and they understand well. Well, this is the low net present cost option by a lot, $10 million less. It can be very good business, and that's why you see so many companies, Walmarts of the world, Pepsi's, Procter and Gamble's, others, very interested in sustainability programs. A lot of consumer benefit, and it pays. So in conclusion, you don't have to start with utilities, but I think it's a pretty good place to start because the technology is well known. We can wrap our minds around it. A lot of times we can get help from local utility systems. Governments, sometimes they get very generous. They'll give you tax breaks, investment tax credits to put in things like solar and windmills and other things. So a lot of people want to help in this area, and you aren't in it alone. And there's a lot of literature, and there's a lot of technology and a lot of knowledge out there that can help you go. So it's maybe a little bit easier to wrap your mind around than some of the other systems. And as we talked about, 20 to 30%, pretty easy. If you start getting up into cogen, then even larger numbers, because you're taking advantage of using energy on more than once, 2 times, 3 times, and the savings can become pretty significant. The same approach, I know many that are listening know this basic loss approach works equally well on making systems, packing, logistics, infrastructure. I mean, everything we do, because of there are inefficiencies in systems, and there's also new technology coming out all the time that can provide expensive labor resources and expensive material users. You can find a better way. So all these other systems go, but again, you got to start someplace. So with that, that wraps up our regular slides for today. I've got a few more to go through. First, I wanted to do a free offer. You're actually helping us. Think of this as a beta test. We've done a little bit of work over the holidays to look at just steam systems as part of our master planning work, as part of our loss work. One of the things we do is we will go into plants and we rate different utility system operations based on their ability of meeting production needs and whether they're safe and whether they're reliable, and maintenance and operating strategies and spare capacities, and do they have enough spare capacity? If you lose a temperature transmitter, does that mean you lose important production facilities? So, and then of course sustainability that we were just talking about. So we've done, again, dozens of plants. We've got a database. We've got some benchmark data on what the best of the plants are doing, what the average plants are doing, and this data is really easy. We've got a survey that's about 20 yes or no questions that you could give it to your steam person. I think they can fill it out in about 5 or 10 minutes. Email it to us, and we'll we'll put together this report and shoot it out to you. So it'll give you a little bit to judge, and we're going to take a cut, and this is where it helps us. We talked about two different ways of looking at the gap analysis: top down, bottom up. What we have started putting in place here for the STEAM system is looking at pieces that make an efficient system, and we've put an expert system together, simple artificial intelligence system, so that if you don't have certain aspects of your system checked off, that might be worth 1% or 3% or 5%. So we're trying to come up with yet another approach to close the gap that we think even targets individual customers even more. Also, viewing this webinar is good for a professional development hour. Shoot us your information. I'll put up my name and contact information. Request your form. We'll sign a document and get it out to you. So we've got that for you. Also, I want to remind you that we've got a training session coming up next month, February 19th. We're going to look at best value option analysis. It's part of how do you get decisions made when they're difficult to make, and a good logical approach. And we think we have some good information to share. We'll be covering topics like why it's important. If you want to be sustainable, you need to be able to talk this language of management, and feeling comfortable with things like net present cost, and we'll include that. It's also very important to have a master plan in place to make decision making easy. And a lot of times people, I think, give up a little bit too easily. A project could be appropriated, but they haven't considered things like equipment obsolescence, maybe the new project coming downstream as a way to try to fund the project, and we'll get to talk some of those topics. So I think there's some interest for folks. Spread the word on it, and happy to share what we know and can find helpful for you. So thanks for participating in today's session. If you have any questions, again, there's a chat space bar. Put them in the chat space. We'll get answers back to you as quickly as you can. I will also leave this slide up for the next 10 minutes or so. Take my contact information. Feel free to give me a call, email me, and we will get back to you with an answer as quickly as we can. I really appreciate your attentiveness. I appreciate your interest. We've received several very favorable comments, so we hope to keep doing it, and we will keep doing it as long as their interest, and we're hoping it's helpful. And if you have ideas for future topics you'd like to hear us talk about, we can reach out to our network. We've got some folks that can share some very, very insightful information that we think will help you on your journey. So with that, thank you very much. Have a great day, and I've enjoyed spending some time with you. Thank you.